Hello, class. I want to make just a brief comment about the use of Desmos for doing exercise about calculation of mean, median, standard deviation, and all that stuff. Okay, so somebody brought me into the table this exercise. Okay, in this exercise that is from your homework. Okay, and in this exercise, well, you need to compute the mean. And they are giving to you in the exercise with the frequency distribution. Getting the frequency distribution as an input, that is very easy because you take the blue column, add all the values, and then divide it by the length of the sample, which is in this case 50. Okay, now this is the frequency distribution. This is not really the actual data of the sample. Okay, so this is the frequency distribution that is coming from the raw data that was sampled, okay, to create this frequency distribution. So if you want to use Desmos in order to compute the mean for this type of exercise, you need to reveal the data. Now, from the frequency distribution, you're going to be able to reveal the data because the data itself, the outcomes of the data itself are all this first column in the left. Okay, this is the lowest value of the outcome, and this is the highest values of the outcome. Those are the outcomes, the different values that you have in your data. But for every output, okay, you have different frequencies. That means that the data, when it was sampled from the population, there were many people that really have the same score. For instance, in here, what this table or this frequency distribution table is telling to you is that in the people that they surveyed, there were three people that have a score equals to 1. And also, if you go down, there were 9 people that were sampled that the score was 2. And if you're going down, for instance, there was people that got a score of 12. How many of them? 1. How many got 10? 4. Okay? So you can reveal the data, the original data from here, okay? You cannot use this information straight ahead in order to input into Desmos. You need to reveal the data. So the way to reveal the data is create a table in Desmos as the one that here. This screen that you see here is Desmos. And then you reveal the data. How do you reveal the data? Well, in the following way. Okay, how many people I have that got a score of 1? Well, I have 3 because the frequency of that score was 3. So I have 1, 1, and 1. How many people I got that the score was 2? I have 9. Okay, so I need to input 2, 2, 2, 2, 2, 2, 2, 2, 2. How many times? 9 times, guys. Okay. How many people got a score of 3? A. 1, 2, 3, 4, 5, 6, 7, 8, and so on. Then all this column that you see here, okay, that is the original data that was sampled. And from this column, you can derive this frequency distribution in the way that I show you in one of my videos when I was talking about this topic. Okay, so this is really the original data. Now, when you go down, that you input the original data, okay, into Desmos, then you compute the mean, and the mean is 494. Okay, that is the value that you have over here. Of course, in here, if you're going to make this exercise, for instance, let's say that you have this type of exercise in your test. Okay, well, it's going to be faster to do it from here than input that one into Desmos, because in Desmos you need to reveal the original data. The point is that what happens if I ask you, instead of the mean, to compute the standard deviation? Okay, let's say that you have an exercise in your textbook in which I provide you with the frequency distribution of the data, not the data itself, the frequency distribution of the data. And I ask you, besides the mean, I ask you to compute the standard deviation, where if you need to compute the standard deviation, you cannot compute the standard deviation directly from the frequency distribution. You need to reveal the data, okay? And once that you reveal the data, then you compute the standard deviation. So you go here in Desmos and you write down STDEV of the variable y1, which is your data, and now the standard deviation you can compute, that is 295. But in order to compute the standard deviation, you need to reveal all the data from your distribution frequency, okay? And actually what you see here in green is the histogram of this data. You can see that this histogram, okay, is not really a center histogram. It's linked to the right, so that's what I call a skew to the right. And the mode is now 494. No, the mode is actually another one. Well, is a little bit higher over here. I don't know what these values be, but this is 5, 6, 7, 8, 9. Yeah? The mode is 9, but it's not actually the mean, because the mean has the bias of another numbers, okay, of another outcomes. Okay, well, this is the comment that I want to make, just to avoid some confusions that you may have in the use of Desmos to make the computation of that. In Desmos, you need to have, remember, you need to import the original data. I mean, all the events. This one is a summary of the original data. Okay? Well, thank you guys.